Hello, how's it going? So this is part 2 of our series, Train Models on NHL 94. So if you remember part 1, we trained a model for 30 million time steps. That's 6.5 hours on my RTX 2060 Super, so that's quite long. Even after all this training, it didn't manage to score a single goal. It was good at defense, thought. It was good at intermediate goals like passing, shooting, body checking, winning face-off, because we give reward for these steps and they are quite easy to achieve. But for the more long-term complex reward of goals, it didn't manage to achieve it. So if you remember, the next step was to first tweak the reward, like give less rewards for the intermediate goals and keep the maximum reward for the goal only. This we're going to try in a later video. But so today we're going to try the other alternative is to train on simpler examples first and build a model like that with simpler examples. And first, in this video, we're going to try with the shootout mode, which is a simple one-on-one. So first, I created a state with the shootout mode. So if you want to, if we do a reset, so you select shootout, and you select your teams. So I already saved the state. So it's called shootout manual. So manual means for manual goalie, because I want also to train the goalie against the opponent. Shootout is with automatic goalie. So we're gonna use a manual goalie. So this is me playing. So it's very simple. If you don't know hockey, it's very simple. Just shoot once against the goalie, and after that, it's the opponent's turn, or he tries to score against your goalie. In this case, we control the goalie. It goes on like this until there's a winner. So first, let's see our reward function. The reward function is pretty simple. So we give a reward when we score, and we give a penalty when the opponent score. And when the round finishes, we end the session. So it restarts the session when the first round finished. So if you watch the first part, you might ask, what about the other metrics like shooting, scoring? Shooting and passing, and also offensive, being in the attack zone. So for some reason, these metrics are off. I don't know why they turn it off. So if we shoot, you see that the value doesn't increase. So we cannot base our reward on that. But as you will see, it's enough to build a successful model anyway. Okay, so let's start the training. So we're going to train for 3 million time steps. Obviously, we're going to use the NHL 94 Genesis environment and the shootout manual state. And we're going to play the result at the end. So 3 million time steps should take under an hour. Let's start. So while the training is progressing, if you're curious about the CPU and GPU usage, so here you go. So as you can see, the CPU usage is quite high because it's running the Genesis simulator on 24 threads. on each of the 24 threads, and it's quite consuming. So basically that means that the CPU can easily be the bottleneck. So before going out there and buying a super powerful GPU, make sure your CPU can follow, because if you can only run, let's say, four emulator cores at the same time, most likely it's not worth it to upgrade your GPU much. Your CPU will be the bottleneck. So as you can see, we can probably run 2 experiments at the same time with almost 100% capacity. For the GPU usage, the GPU is obviously underutilized. That's because it's waiting for the CPU to produce the data. So the GPU runs the game, collects the rewards, the information about all the frames and the resulting rewards and the action taken, and sends it to the GPU. So the GPU only works part-time and in spikes. The VRAM usage is quite low, as you can see. This is because we're using a 1.7 million CNN model, which is not so big. And don't forget, there's an overhead of 400 megabyte because of Ubuntu, so it's actually using 1.5 gigabytes of VRAM. If you use an Impala model, it will be bigger, but still way much under 8 gigabyte. Also did a tool called, it's the first time I talk about it in a video, so called AI-G. So you can install it with this way, and after you launch this way. So basically this tool shows the CPU and GPU usage at the same time on the timeline. So I find it useful for this type of task because you see when where's the bottleneck and when the GPU is waiting for the CPU. So you see the CPU is doing most of the work, and you see when it's waiting for the GPU. Also the PCIe bandwidth. PCIe transfers are sometimes a bottleneck, so be careful about that. 16x, PCIe 16x or 8x, even 4x is okay. But under 4x, you're going to start seeing a big downgrade in performance because there's still quite a lot of data to transfer. Remember that he has to transfer all the frames, all the 84 by 84 frames to the GPU. So that's quite a lot of data. I talked about these bottlenecks in more detail in the previous video about the videos on mining hardware, so you can take a look at that if you want more details. So tell me what you think about this tool, if you have any suggestion on how to improve it. To me, it's useful, but there's still rooms for improvements. Like the PCIe data is a bit needs to be fixed, and also this I forgot that this supports multiple GPUs and also AMD GPUs. So if you have a RX 580 or any AMD card, it will work. So you will be able to see these metrics. Except the name, there's a bug with the name. And also it can work for both NVIDIA and AMD card at the same time. So you can see all your cards there listed at the same time. So please comment down below if you have any suggestions or criticism about that. So the training is almost done now. Let's see how it goes. The reward is close to 1. Okay, so that's good. It starts with a goal. So while you're seeing 24 games, it's actually the 24 environments running at the same time. So it was training on 24 environments at the same time. So it just displaying those environments. So it's pretty good at scoring goals. But the problem is that it's always the same situation. So it just needs to find the right trick and repeat it, and the right flaw in the goalie, and repeat it, and it works. So that's not too hard. And for the goalie against the opponent, seems to be okay, but still a bit shaky. As you can see, sometimes it scores. Anyway, overall, the results are quite good. So let's take a look at the Tensorboard data. So Tensorboard. The current directory. Okay. So as you can see, it started progressing at around 600,000 time steps, and constantly improving past the 1 million mark here. And it's really close to 2 million time steps that it's getting more stable. So 2.5 million is enough to train a very successful model. Not perfect, because it seems that it gets the opponent can still score goals, but good enough to dominate. So next step is to have a more complicated example where you have a defenseman. I'm not sure how I'm going to do that yet. Probably start a 2-player game and artificially try to place the players before saving the state, or I can find the position of the players in RAM and change the values directly. Not sure I'm going to do it yet, but I will find a way. So that's good news. So it I think with the shootout example, I could think about starting some sort of contest or tournament. If you have any interest in that, please tell me, or any special request. Please comment down below. So either I plan to start a tournament with the shootout or a full game. A shootout might be a bit boring, because if it's easy enough to for 2 million, 2.5 million, if after 2.5 million time steps it's easy enough to dominate, it might be a pointless contest. But that said, if you control the goalie, if you can build an AI that control the opposing goalie successfully, you might be able to make it much harder. So I still need to think about details. I'll let you know. So that's it. If you have any questions, please ask, and don't forget to like and subscribe. Bye. Now I'm gonna watch Squid Game.